Okay, so in this video we're going to find the equation of a tangent line to a path in R3. This is a curve cosine t sine 2t e to the negative t squared. And I'm going to try to find the tangent line at gamma of pi. So the tangent of this curve, we're going to make a picture a little bit in GeoGebra, but schematically we're defining a curve, right? And then we're going to have a point, gamma of pi. Sorry, this is backwards. Oops. We have a point, gamma of pi. At that point, I'm going to need to find the tangent vector, gamma prime at pi. And the line that I'm going to find is basically this line that we're trying to see here, right? So that line is the one I'm going to find. Of course, it's going to have to go through that point, so something like that. So the function that we know that will be a line, we know it's going to be L of t. We've done it p plus t times v, where p is the point. So p would be a point on the line. So b in this case would be gamma of pi would be my p. And the v vector is going to be exactly this guy, the direction of the tangent line, so gamma prime of v. Gamma prime of pi would be the tangent vector. So that's the goal. So we need to find these few things. We need to find gamma, we need to find the derivative, we need to find gamma prime, and so on. So okay, so let's go for it. So I'm going to have space for this, so I'm going to leave that. So I'm going to find p. So p is a gamma of pi, which is pretty straightforward. Cosine is going to be cosine of pi, sine of 2 pi, and e to the negative pi squared. So whatever that is, cosine of pi is negative 1, this is a 0. I'm going to write this one like 1 over e to the pi squared. So that's my p. Okay, so we got our p. P is, I'm going to copy this and put it right there. Okay, so now I want to find gamma prime. So the derivative is going to be from here, it's negative sine t, comma, derivative of sine is going to be a 2 cosine 2t, and the derivative of e to negative 2t squared, it's going to be negative 2t because of the chain rule times e to a negative t squared. Correct. So that's my gamma prime at t. So now I'm going to find this gamma prime at pi. It's going to be negative sine of pi, 2 cosine of 2 pi, and negative 2 pi e to a negative pi squared. I want to write like the other one, so e to a negative pi squared in the denominator, like that. Okay. So this is, when you plug in these numbers, sine of pi is 0, cosine of 2 pi is 1, so it's a 2, and this is just negative 2 pi over e to a negative pi squared. Okay, so this is my v. This is going to be my v function. So let me put it here equal, and let me select that, and I'm going to change the color and make that one to red. Okay, so now I got it. All I need to do to find the equation of my line, L of t, we said was going to be my point P plus t times, I'm going to make this for now green, this t times the vector v. Now something a little bit, it's not a big deal right now, but in case later we want to combine the time, if we think of the gamma of t like a path, and the point is following the time t, this t over here, that t is totally different from this t over here, so just be careful later, maybe in some problems. These are two different, if you think of these like paths, they're not the same t. Okay. For what I'm doing right now, it doesn't matter. Okay, so my function is going to be L of t. My line is the point P, so I'm just grab it from here. I'm going to cheat and copy. And let's put it here. And then I'm going to do plus t times the vector v, which is this. If you put this all together in one, I mean, we can't do much, but when I put it all in one thing, I get negative 1. I have a 0 over here. Then this is 0, so we just get 2t, comma, and I get, I can factor the 1 over e to the pi squared. Oops, here I did a mistake, right? I put the pi 1 on the denominator, and then I erased this. It's not negative anymore. But you probably noticed that. I have it from here. This is not negative. I put it in the denominator. Oops, that was too big of an eraser. Okay, negative 2 pi. I have a 2 here over e to the negative pi squared. Oh, that's the problem. It's not negative. Sorry about that, guys. There you go. E to the pi squared. It's correct over here. Just it was right over here. So e to the 1 over e to the pi squared times, I'm going to put 1 minus 2, and I erased it here. So 1 minus 2 pi t. Okay, so 1 comma 2t comma 1 over p pi squared times 1 minus 2 pi. Okay, so this is my equation, and I'm going to keep going, and I want to do a graph of this like we have done in the other videos in GeoGebra to see that this actually makes sense. So I'm going to try to have GeoGebra written here on the side. It's going to be hard to have both the same screen, but just while I type them, just while I type the this here, I'll do it. And to save some space, I'm going to get the calculator, the type keyboard for my iPad. Be sure I don't press anything weird on this one. Okay, let's try to get here. So I guess now I can type here my function, which is just my curve. I'm going to first put the gamma, which is cosine t, sine 2t, and then it's e to the negative t squared. So that's my curve, gamma. Okay, so I can zoom in a little bit here. We'll see it more carefully in a minute. So that's my curve. Something like a little curvy there. It's not, it doesn't overlap. It's different heights. They right there on 0, 0. The point that we got is the point, I can type it here. The point where I'm doing this is the point negative 1, oops, negative 1 comma 0 comma 1. I can just write e to the negative pi squared. So it types here a 0, negative 1, 0, 0, if you see that. And it's really not 0, 0. If you click here on my computer, if you go to here, it's a very small number, so it's approximating to 0 here. But and you do it in a browser, this is not going to be 0. I'm trying to type to click on it, but you can't see it. But if I click on this, you see it's a long decimal. It's not 0. But it's the point that we got here, the point A, right? It's the point of tangency. It's the point A that we got right there. Okay. So now I'm going to graph the line, and the graph the line I'm going to get should be the line that is tangent to that curve at that point. So the line, I'm going to type it as I have it here, and I'm going to type it as I have it all together. Okay, I'm going to type it like I have it over here in my marker. I'll type it like negative 1. But you can see what's going to happen with GeoGebra. Then I write 2t, comma, and see how it's separating here. If you notice, it's separating already like the vector negative 1, 0 plus t times 0, 2. Even though I'm writing it in one thing, GeoGebra is separating the constant part and the t part. So I want to keep writing it like this just so you see that that's what it does. And then the third part is 1 over e to the pi squared. I'm going to write like that. just because that's how I have it, times 1 minus 2 pi t. I think that works. See. Okay. So I typed it, there's my line, you see it here. So let me go now make this bigger. So I don't need to see that anymore. Here's my line and my curve. And if you see it here, you just see that the f function that it did down here, it's not 0, right? We're at the 1, 0, 005 plus 2 times this. So it has some, and the lambda is defined like my 1 over 2 pi squared, I guess. Sorry, the lambda is my t value. So here it's putting 0. But this is the point that I'm getting the curve gamma. There you go. Sad that we get these things black. Let me change the color. So pick another bright color for the line, something like that. There you go. Much better. Okay. So that's the line, and that's the point, and I got the tangent to that line at that point. Okay? Okay.